Well, hey guys, welcome to charging. All right, so kind of want to go through a few things before we get into doing the assignment. One of the things I want to show you is that, well, charging, it's kind of the opposite of starting. And the reason I say that is because with a starter, we use some current passing through a wire to make a magnetic field. And we saw that. We saw that with our little compass, okay? And that's pretty cool because what we did with that was we used that current from the battery to turn the starter to start the engine. But here's the opposite side. With the alternator, what we're actually doing is using the engine to spin the alternator so that we can put power back into the battery, and you've got to power all those other things that you've got going on, such as headlights and air conditioning and of course the bumping stereo. Yeah. All right, so here's a few things that we've got going on. All right, one of them is if we pass a magnetic field by a wire, it actually induces a current. So that's kind of the opposite of what we saw before when we ran the current through the wire, we made the magnetic field, and we made our little compass go round and round. All right, kind of cool. So when we do that, we're actually able to make a current so we can provide that electrical power. Cool. And of course, the alternator is being spun by the engine after it starts, okay? But we've got a bit of a problem. An alternator makes alternating current, okay? What that means is the current goes positive and then negative and then positive. So we've got to do something about that, and we can. We use this little tiny component called a diode. And what that diode does is it allows current to go one direction, but doesn't allow it to go the other. So if you put it in the right orientation in a circuit, when the current goes positive, it passes through. When it goes negative, it stops and it doesn't move. So if we make a circuit that has these diodes in it, what we can end up with is direct current, or DC. And that's important because batteries only use direct current. That's all they work with. Okay, so now we've got this kind of going on, but I wanted to show you something so that you believe me. Alternators do in fact make power. So here we have our little light bulb. We have an alternator. We have a battery so that we can energize the magnetic field inside of this. And then we're going to spin it and we're going to actually make some power. So if I spin it now, pretty easy. It doesn't spin very hard. Okay. So I'm going to add power to the magnetic field. And now when I feel it, ooh, there's some drag. So I can tell it's going to make some power. Watch this. Ooh, there's the magnetic field already there. Okay. So as I spin it, I start to spin. Look at that. I can actually make the bulb light up because I'm passing a magnetic field by a wire to make current. Nice. That's really cool. Okay, so what you're going to see are a few illustrations in your notes that kind of go along with how this circuit is put together, what works, but there's also one that shows a diode, and it has a picture of the current going up and down, and then a little diode, and on the other side, just the current on the top. So that's kind of the stuff that's going on. I'll have another video for you that has to do with the slide deck to show you what's going to go on with the cars, and you got to do some questions and, of course, make your slide. All right, guys, I will talk to you soon.